Well, good morning, everyone. I am Scott Grams. I'm the Executive Director of the Illinois Landscape Contractors Association. ILCA is pleased to partner with Belgard today on today's webinar entitled Introduction to OSHA Silica Dust Law. Belgard was instrumental in helping us locate today's speaker, Tim Hinker, and Tim is the National Design and Construction Specialist for Anchor Wall Systems. ILCA, over the course of the past few months, has fielded dozens of calls about these new standards since they were put into place late last year. And at that point, we had very few answers as the new standards were very new. We realized quickly we needed to identify a subject matter expert to walk us through the changes to protect our members' workers from liability, injury, and of course, future health concerns. So working with our friends from Belgard, we were able to identify Tim and are pleased to have him participate today. A recording of today's webinar will be posted to ILCA's website for ILCA members to view after the fact. If you're not an ILCA member, please visit our website for information on how to join so you don't miss out on excellent education like this in the future. A couple of housekeeping notes before we proceed. One, I ask that you please put your phone or computer microphone on mute. This is especially important if you are using a mobile phone or taking the call in a conference call format. Two, if you have any questions, please enter them into the question box you see on the screen. We'll answer as many of those questions that we're able to at the end of the workshop, and please be advised we may not be able to answer them all given the time frame we have today. Lastly, at the end of the webinar, you'll be sent a link to an evaluation survey, so I ask that you please take a few seconds to complete the survey and offer us feedback on future webinar topics you'd like to see covered in this online format. So again, on behalf of the ILCA and Belgard, I'd like to thank you all for joining us, and I will now turn the webinar over to Tim.
All right, thank you. Thanks everyone for joining us this morning on what I feel like is an incredibly important topic for our industry. I am Tim Hinker with Anchor Wall Systems. I'm based out of Minnetonka, Minnesota. I've been the construction and training specialist for Anchor for 12 years, but previous to that, I was a landscape contractor in the Minneapolis market for about 20 to 25 years. So over the years, I have cut my fair share of concrete and have probably caused a fair amount of silica to go up into the atmosphere. So as I've been learning about this topic myself in the last several months, it is a very confusing topic, and I'm going to do my best to answer some of the very important questions about it, but I want to make clear that this is an introduction to the silica law and is in no way going to be 100% complete, and I'm not sure any training you do on this subject may be 100% complete. So my recommendation is get some information today, but continue to do research on your own and find additional training resources on this topic, because it is something that is going to affect basically every contractor across the country, whether it's in the landscape industry or masonry industry or any other kind of industry that creates silica. So with that said, I'll kind of get going into this, and like he said, we'll have a question and answer at the end. So we'll cover the health effects of silica, some of the controls and personal protective equipment requirements, and then talk about some of the new rules with it, which include a written exposure control plan, medical surveillance requirements, and some of the other things that you're going to need to know. But essentially, we start out with what is silica. Crystalline silica is a common material that it will occur in many naturally occurring and man-made materials, and many of them are used on construction sites. Some very common ones, obviously, are our block and brick products. It's in natural stone, and pretty much anything that you encounter that you cut or crush that creates a dust is probably going to have some silica in it. respirable crystalline silica are very small particles, typically 100 times smaller than an ordinary grain of sand. So in reality, the particle, an individual particle, you probably would not be able to see with the naked eye, but if you are creating dust, then you are actually probably already overexposed according to the new silica laws. What happens is very small pieces. Can you guys hear me all right?
There's just a bunch of people saying they can't.
Is anybody there? Can they hear?
Yes.
Okay. Just want to make sure.
Yeah.
All right. So with the silica, the dust that gets in the air gets breathed in and then trapped in your lungs. So the crystalline silica has been deemed hazardous to your health, and we'll go through a couple of different ways that it is. So we talked about the size of that silica dust particle. The large circle on that screen is actually the diameter of a human hair, and the crystalline silica dust is the yellow circle down there. So you can see it's a significantly smaller particle than you really aren't going to see it with the naked eye. So the new OSHA regulations, based on kind of statistics, we know that more than 2 million construction workers are regularly exposed to silica dust at a job site, and roughly 30% of them are at levels higher than the OSHA standards. So it's not going to be very difficult to go above those standards just by really hammering, chiseling, cutting, whatever it happens to be. When dust is flown into the air, you're going to be at that limit. So here's some areas where we would probably see silica dust going into the air, or what the materials that we use would create dust. You have stone, rock, concrete, brick, block, mortar, cement, or tile. Many of those in the hardscape industry, obviously we're dealing with brick and rock and block, and anything that we do with those, we run the risk of silica being launched into the air. And with those, a lot of what we do, again, from our techniques are demolition, any drilling that we do, any sanding, tuck pointing, grinding, all of that is stuff in the hardscape industry that we are dealing with on a regular basis. So as we go through this, here's some of the health effects that have been exposed, that silica exposure will possibly create. It's been linked to asthma, it's been linked to dermatitis, eye irritation, silicosis, nasal dryness and obstruction, and then in some cases prolonged illness. So none of it has, my understanding is none of it is a direct cause, but it has been linked to a number of these. And silicosis is probably the worst of those, and it is an irreversible, often disabling, and sometimes fatal lung disease. So essentially what happens, I think similar to cigarette smoking, is silica is ingested into the lungs, it traps itself in there, it blocks airway passages and reduces the capacity of the lungs to filter the air. So there's three types of silicosis: chronic silicosis, which is the most common, which happens over a 10 to 30 year exposure. We have accelerated silicosis, which is more fast acting, and it may occur over 5 to 10 years. And acute may occur within a few months to less than 2 years, depending on kind of some of it will be with what your susceptibility is to it. So it is definitely something that is a concern for everybody in our industry, and should be a concern of everybody in our industry, because we want to try to maintain, healthy crews and healthy people in our work. So with some of the symptoms that you will see is shortness of breath, cough, fatigue, night sweat, fever, and then sometimes you get a lot of that. The earlier stages, there may be no symptoms in the earlier stages of this disease, so it could come on quickly near the end. And I've always I've kind of pointed out, since this whole scenario with the silicosis and the silica dust has come about, I've actually gone in and gone through a lot of the testing, just because of, worried that I'm, if I'm going up the stairs and I'm short of breath, I'm like, okay, is this a problem from silicosis, or is this just me being out of shape? And so all the medical testing and stuff that has happened, I've gone through it. Thankfully, I didn't have any signs of it, so it's definitely worth having a look and taking a look and getting checked out for it. Some of the other health effects of silica is silica exposure has been linked to COPD, several types of kidney disease, autoimmune conditions, and then also some types of TB or latent TB, and then of course the really bad one is lung cancer. So the exposure has been linked with all of those, and so the less exposure you get, obviously the better off you're going to be. So what is the new standard? Well, OSHA's new standard, which went into effect in September of 2017, so it is in effect right now, and OSHA could come out to your job site tomorrow if you're working and do an inspection. You will have to be in compliance with this as of right now. Employees must use engineering controls, work practices, and personal protective equipment when exposed to respirable silica dust. Employees receive medical examinations under certain circumstances, and we'll talk about those in a little bit. And employees receive training on respirable silica dust and understand the controls and personal protective equipment in place and how to protect them from exposure. Employers must write a written exposure control plan on how to handle scenarios where silica dust is being created, and then employers also must understand the exposures of the employees themselves. So that's kind of the overview of the silica rules. And here is how it changed. In OSHA, the permissible exposure limit, or PEL, was 250 micrograms per cubic meter of air. After 2016, the permissible exposure limit is now 50 micrograms per cubic meter. So they cut it by a fifth. So it is incredibly, it was low before, it's incredibly lower now. So essentially, like I had mentioned before, if you see dust in the air, that is going to be over the permissible exposure limit. Now, that permissible exposure limit is time-weighted average over an 8-hour workday. So it may be a 5-minute exposure isn't going to throw you over if that's all you do in a workday. But it's still, understand that if you see it, it's going to be above the exposure limit. So the PEL or PEL permissible exposure limit, the employer must ensure that no employee is exposed to an airborne concentration of respirable crystalline silica in excess of 50 micrograms per cubic meter, calculated as an 8-hour time-weighted average. So there are going to have to be controls in place to minimize the amount of dust in the air, or a much more stringent policy on respirators and allowing the worker to be able to work in the environment and not be breathing the crystalline silica itself. So here's some of the things you should be able to do that can protect yourself. Understand the tasks that happen on a job site and which ones can generate silica dust, and minimize the exposure of that. Understand the new silica dust regulations and requirements. Use engineering controls, and we'll talk about those here in a little bit. And follow the proper work practices and manufacturer's instructions. Use proper respirators. Review the written exposure control plan that your company has in place. Avoid working in dusty areas when possible. Attend medical screenings if required, and follow your doctor's instructions. So some common sense things in that, but definitely worth a review. And another thing that maybe sometimes gets lost in the shuffle is good personal hygiene, not eating or drinking or using tobacco products in those dusty areas, washing hands and face before eating and drinking or smoking outside dusty areas. Do not use compressed air on clothes or surfaces. You know, if you got your air compressor and your clothes are all dusty, the habit is to just blow yourself off and get yourself clean. If you're going to conduct that practice, make sure you're wearing a respirator, because you're basically shooting the silica dust back into the air. Do not engage in dry sweeping of small dust particles, and bringing a change of clothes before getting in your car whenever practical. I took a class in silica earlier this year, and one of the stories that was told in class was actually a worker's spouse ended up with silicosis, and they could only figure out why. The only reason they could figure out why that she ended up with silicosis is the worker would come home every day with fully dusty clothes, and then he'd throw them in the laundry, and then before the laundry went into the wash machine, the wife was shaking the clothes out and filling her laundry room full of silicon dust, and she ended up with some acute silicosis. So it does hang around. It doesn't, once it goes into your clothes, you know, it will cause a new exposure somewhere down the line. So one of the things that, there's a few things I'm going to talk about that I really want you guys to remember. So if you've got a pen and paper and want to write this stuff down, some of the research that you'll want to do after this hour is all about Table 1. And I have on here that Table 1 is OSHA's gift to you, and that's, you know, somewhat tongue-in-cheek, but in reality it is kind of a gift for the small contractor, because there are several ways to come into compliance, and most of them require a lot of monitoring and a lot of, you know, possibly air monitoring and testing equipment, and then if it fails, you got to figure it all out yourself again. But basically what Table 1 is it's a list of common practices that cause dust on a job site, and what rules to follow in order to be in compliance. So for small contractors that, you know, have a few employees, and we talk about a written exposure control plan, you can use Table 1 as your written as a solution to the tasks in your written exposure control plan. So I think you can go on to OSHA, or if you Google OSHA Table 1, you'll be able to find this form. And if you are following Table 1, you are basically in compliance. So again, you never know with OSHA how they will respond when they get out to a specific job site. But my understanding is if you're following Table 1, you will be in compliance with the new OSHA dust rules. So, for everybody out there, I would write down Google OSHA Table 1 and find that form and be aware of it. It'll tell you, I'm cutting wet outside, no respirator required. I'm cutting wet inside, respirator required. And it'll give you some kind of rules to follow to ensure that you are using the right controls or the right personal protective equipment. So some of the engineering controls, when we talk about those, are, and if you're familiar with OSHA's small business safety plan, engineering controls are basically ways to eliminate or minimize a particular hazard. So we're doing a couple of different things to control silica dust. The two very most common are going to be wet cutting or having some sort of vacuum dust collection system. Those are your two primary engineering controls. There really isn't any out there that I'm aware of. If you do some more Google searches on OSHA, you'll find a lot of really good videos, and most of those videos, because both the vacuum manufacturers and the saw manufacturers are on top of this new law and new regulation. So they've actually got some really good videos on YouTube relating to their products, but how those products will help you be in compliance. So be aware of that. Again, do some more research, but your two biggest, understand it. When I do this class, I normally say the biggest thing to remember is don't send up a big cloud of dust. And one of those ways is going to be the wet cut. One of them is going to be the vacuum cut. And if you're not setting up a big dust cloud in somebody's backyard, you run a much lower risk of having somebody stop out to your job site. It's going to be beneficial to your employees from a safety standpoint and beneficial to your company financially as well, because there are typically fines involved when OSHA shows up at your job site. So understand the proper use of the engineering controls and follow them. If you're unsure how to use the controls on it or a problem arises, notify supervisor immediately. Properly inspect the equipment, make sure that it's in working order on a regular basis. Large amounts of visible dust or a noticeable increase in dust generation during the task normally indicates that controls are not fully or properly implemented. So, and just one of the things with engineering controls is that it has to be, if you're cutting wet, it has to be a manufacturer's installed wet cutting system for that piece of equipment. So in other words, you can't start cutting through a brick and have a second employee hold a garden hose onto the brick or block and cut through it. That doesn't qualify as an engineering control. It has to be something that is attached and made for whatever model equipment that you're using. You can't just kind of create your own ad hoc control. So, and then follow work practices. For silica exposure, when performing tasks, think of different ways that you could do that task and that would reduce the likelihood of exposure levels. Work practice controls will vary based on the task and the equipment used. The other thing I bring up a lot of times is think about the products that you're using. There are products on the market that might minimize the amount of cutting that will happen on a job site, or you might be changing a pattern in your pavers so that you can lay a pattern that you don't have to cut. So just different ways where, you know, if you can just reduce or eliminate the need for cutting on a particular project, then you can really reduce the amount of crystalline silica that'll be exposed. So different things to think about with the wet methods is full and proper implementation of water controls. Again, it has to be something that is on site or attached and is supposed to be on that piece of equipment. Flow rates are specified by the manufacturer are used. Clean water is always really important, an adequate supply of clean water. So it has to be a constant supply, or at least something that it's harder to recycle it and keep it clean. The spray nozzles are working properly. They're not clogged. All hoses and connections are intact. Any filters are rinsed and replaced often, and water is replaced or changed when it gets gritty or begins to slip up the dust. So there's a number of different pieces of equipment that are available on site or available to contractors for wet cutting. We're not going to really get into those, but you could get handheld, you can get table saws, you can get walk behind. The big thing is to remember, and this is why I caution everybody that this new rule is kind of a moving target, in that you can cut wet, but all of the wastewater accumulates on the ground. Number one, it could get your work surfaces dirty and you need to rinse them. But one thing to remember is when you cut wet, the waste falls to the ground and it dries. It turns back into silica dust. And when you start to sweep it, now you're being exposed to it again. So just because you're cutting wet doesn't necessarily mean that you are in compliance, because once that material dries, it goes back to dust form and there's going to be issues. So just be aware of that and try to eliminate as much of it as possible. The dry method is, again, vacuum systems. There are vacuum systems for grinders and saws and anything else that might possibly create dust. Make sure the shroud is intact. Encloses most of the grinding blade or saw blade. Hoses and connections are intact without kinks or tight bends. And the vacuums have enough power to, or enough suction power to capture the dust at the cutting point. Now, there are regulations on the vacuum systems that you use and the filters, and that is important to remember and to understand. Some of it has to do with the horsepower in the vacuum itself. Some of it has to do with the filters that the vacuums use. All of them need to have some sort of filter cleaning mechanism, like the top picture there. You can spin it and clean it. Some of the vacuums have what's called a pulse back, where it blows the filter out every few seconds. So it's not just using a shop back, because a shop back filter will clog on a fairly regular basis, and there's no way to clean that without tearing the whole thing apart, shaking that thing out. So some of it actually also says to use dust collection bags and make sure that they're emptied to avoid overfilling. So you're not just taking a vacuum and dumping it into the dumpster, which is going to create a big cloud of dust. It actually will have some sort of collection system, and you can just dump the bag then in the garbage. So housekeeping also can create dust, and if you think about your warehouse or your shop and the act of sweeping itself, a lot of the stuff that's settled onto the floor of your warehouse or shop can be silica dust. and needs to be, you need to be aware of it. So some of the recommendations for that are to use wet sweeping, so either kind of mist the floor a little bit to cut down the dust and then sweep it, or vacuum it. And then also they have sweeping compounds where you can sprinkle a sweeping compound onto the floor, which is designed to minimize or eliminate dust as you're sweeping. Big key here is do not use compressed air to clean surfaces or clothing, because again, that will just generate a significant amount of dust again as it goes. That's the engineering control. So again, wet cutting and vacuum cutting, and then we get into personal protective equipment, or respirators. Wearing your respirators while installing or implementing controls for work practices. So even if you're using a vacuum system or a wet cut, it's not a bad idea to have a mask on. And if you follow table 1 that I talked about earlier, sometimes it'll say you need to have a respirator, sometimes you don't. What we know as a dust mask is actually a respirator. Work tasks for engineering controls and work practices are not feasible. You should be wearing them. When engineering controls and work practices cannot reduce the amount enough, you should definitely have them on. And then whenever your supervisor requires it. If it is a company policy to wear it, then you should be wearing it. Ensure that your respirator is properly fitted and perform a seal test every single time you put on your respirator.
Cutting concrete.
When well, like me, many of you may have facial hair. That actually affects the fit of respirators, and a dust mask type respirator and maybe some of the other ones. If OSHA comes out and you've got facial hair, that respirator may not
I'll be on your payroll
compliant because it's not fitting you properly, and dust can get in there. So be aware of the rules and how those respirators will fit you. And I also had, in one class, I had a question from somebody that they raised their hand and said, I can give my employees dust masks all day long, and they never wear them, or they put them on top of their head, and I tell them to wear them, but they don't want to wear them. And all I can say to that is it's your company and your money. If OSHA shows up, they don't fine the employee, they fine the owner of the company. And I know it's harsh, but if the employees are not following the rules and wearing the respirators, there needs to be some consequences. The next guy raised his hand and said, I had the same exact problem. My employee was not wearing his mask. OSHA showed up, wrote me a ticket for $1,300. So, and that was just the one guy. If other guys are in the vicinity and they're not wearing a mask, you will get a ticket for everybody that's not in compliance. So this is a rule that will affect everyone, and it's your bottom line and your company. And if an employee is not wearing a mask and you need them to be wearing a mask, you may have to implement some consequences that are not very pleasant. So just be aware of that if these rules will come to bite you here, possibly in the future. So one of the other requirements then for this new silica regulation is a written exposure control plan. Every employer is required to have a written exposure control plan. What a written exposure control plan is: a description of the tasks that involve exposure to silica, respirable silica, a description of engineering controls, work practices, and respirable protection to limit employees' exposure to silica, a description for each of the housekeeping measures used to limit employee exposure, and a description of the procedures used to restrict access to work areas, which will minimize the number of employees exposed to respirable silica as well. So essentially, this written exposure control plan is you go through and you look at what your daily tasks are, and if you are going to take a paver or a block and you're going to cut it, how are you going to control the dust or the silica from that particular activity? Now, you can do it a couple different ways. You can create your own plan and your you can create your own plan.
Will you be right up against the concrete?
And test it and test the air quality and that kind of stuff, which takes a lot of time and expense. If it works, great. If it doesn't work, you got to spend the time and the money to do it again. And if, but for smaller companies that don't really have the logistics and the tracking that you need to track, then I would recommend you could follow table 1 as your plan in that. So the written exposure control plan, no matter what you use for specific controls within a job site, is going to have to be part of your filing system. Know what the plan is, go over the plan with your employees, make sure they are aware of it, and that it will it'll adhere to or follow the OSHA's new regulations. So the second thing, or I guess this is the third thing, is having a competent person that essentially is the go-to person in a company that is that knows about the silica regulations, and they'll be designated to implement the written exposure control plan. Every company is required to have a competent person so that if OSHA shows up, they can say, what's your written exposure control plan? Who's your competent person? And that's really the person that's going to be, I think, having the conversations with OSHA. One of the things that you need to realize, though, is that competent person has to have the authority to shut things down if employees are not following the plans that are in place. And so it can't just be anybody in the company. It has to be somebody that says, wait a minute, we got our exposure limit is way too high. Stop everything. Let's get this under control. Make sure stuff's working, that kind of thing. So, so the competent person is an individual capable of identifying existing and foreseeable silica hazards, but then also has the authority to make prompt corrective measures. Now, this competent person, there is training available from OSHA that will train that competent person in your company. So be aware of that and maybe start to think about who that's going to be and take the steps needed to make sure that they are in compliance and can do what needs to be done to become that competent person. Another thing that is a little bit of a gray area in this is restricted access. And when you are in the process of creating silica dust on a job site, you need to restrict access only to essential personnel when you're creating that silica dust. And that includes an area around your workspace that will keep also clients out, possibly other subcontractors out. It is, and you have to rope it off or designate that area to make sure that it becomes restricted. And you can do that in a number of different ways. You could schedule your tasks when others are not around. You could tell employees to stay out of areas where dust is generated. You could move employees to areas where there is no exposure to dust. And of course, post warning signs, cones, or barriers to keep people out of a specific area. This is important to understand, but at the same time, OSHA does not define what immediate area is. And so that's where, again, it's a little bit of a moving target. Is my immediate area 50 square feet? Is it 500 square feet? Is it 3 houses down? So if you're creating silica dust and you've got a wind blowing towards the neighbor's house, and you got 2 kids over there playing in the swimming pool, and OSHA shows up, will they consider the neighbor's house immediate area? We don't know that. It's going to be based on which inspector shows up. So again, it's very important just to not be creating dust as your number one function. Then medical surveillance is also part of this, and the employer is required to make medical surveillance available at no cost to each employee who will be required to use a respirator for 30 or more days per year. Now, this is important to understand. If they're required to use a respirator from that table 1, if they're doing an activity where a respirator is required, and they do that more than 30 days in a calendar year, then the employer must provide medical surveillance, which will include chest x-rays and lung assessments and all that kind of stuff. But if they're doing a task where they're not required to wear a respirator, but they voluntarily put one on, it counts as a day. Now, the other thing is, when you say 30 days in a year, if you fire up a saw and you cut 1 block, that is considered a day. So think about that. So that's where you might want to designate, instead of everybody knowing how to use a saw and everybody doing the cutting on a job site, you may want to limit it to 1 or 2 people that are really good at doing the cutting, and then that is their focus and that is their job, and it'll be a lot easier to control less people to be able to control the silica dust that is available to them or that they get exposed to. Essentially, all the medical examinations that procedures required by the silica standard are performed by a physician or licensed healthcare professional. The exam is going to include medical work and work history, a TB test, a physical exam, a chest x-ray, and a pulmonary function test. So anything that's related to the lungs is going to be required in these medical examinations. And then the frequency of that is, again, every third, or well, if you are doing silica, exposed to silica in more than 30 days in a year, these exams will be offered within 30 days of the initial assessment. And then they will be repeated every 3 years as long as that employee is employed by you. So there needs to be some tracking with that. And the dated copy of your last professional licensed healthcare written medical opinion must be provided so we can determine when the next periodic medical examination must be performed. So again, it's basically every 3 years if you're cutting or exposed to silica 30 days in a calendar year. So I wanted to point out again from additional resources standpoint, the Wisconsin Nursery and Landscape Association is actually doing a training to certify a competent person. So this is, if you want to write down some of the information from this, and I know that their space is limited and they might even already be sold out, but be aware that trainings like this are going on a regular basis. This particular one is on April 24th in Verona, which is near Madison, Wisconsin. And this is training it is OSHA training, and at the end of the day, if you take the test and pass it, you can become a competent person according to OSHA for your company. So just be aware of that, April 24th. If you have questions, you could contact the WNLA in Madison. So it's something that is available. There's other ones throughout the year that are available. And this is another one I wanted to point out. And this is actually where I got my training, is the Mason Contractors Association. They have a full day kind of train the trainer class. So it goes through and also talks about, they help you with a template on how to do the written exposure control plan. It is an all-day class, and there is a test at the end. So that's 2 additional resources that you could go to for additional training. I highly recommend that this 1-hour class is truly just an introduction, make you familiar with the fact that there is a new regulation in place. It is going to affect every contractor at some point in time, and you need to do additional training and additional research to make sure that you're in compliance. So with that, I have completed the presentation part of this, and we'll be happy to field any additional questions. I think, Scott, you're going to kind of take those and go from there. But again, thanks everybody for joining us, and I hope that this was a nice introduction to the Silica regulations. I hate to scare the crap out of a lot of people with this. Unfortunately, it does, and it is kind of a scary deal because it's kind of like the new asbestos law or the new lead paint laws. It's not going anywhere, and it is in effect as of right now. So we'll take some questions if you've got some.
I've got a question. Would you consider a splitter as a good mechanical device?
Yeah, actually a splitter definitely can work. Whenever I've used them, I don't really get any dust coming out of those. So yeah, that could be a good control measure to minimize silica dust. If it would work with the products that you're using, sometimes a splitter doesn't give a nice, sharp, clean edge like you want from a saw, but it definitely could be something that would be effective for you.
Yeah, I found some splitters on the market now that are very good. They're very clean cut, and they're out there. They're available. The older ones that I have aren't as good, but the new ones on the market are very good. And I think they don't have any dust. I know they don't have any dust when I've used them. And, it's literally a mechanical device and avoids all the issues with the water and the vacuums and cleaning and all that kind of stuff. So if it's an acceptable device, I recommend that be used.
Yeah, there's definitely some good equipment on the market that will help us with this. There's no doubt about it.
I have another question here, Tim.
Yep.
This question is, does the competent person, are they required to have formal certified training?
Yes, that is actually what that WNLA class is the OSHA training for the competent person. So it isn't, you can't just name somebody. I think they've actually got to go out and attend a class and pass a test, and then that will be their OSHA certification for that. That's a good question.
I have another question. Is there silica in asphalt blacktop?
Oh, wow. I don't know the answer to that specifically, except I know there are aggregates in blacktop, and my guess is that those aggregates have silica in them in many cases. I don't know if it would be in all cases, but I bet in many cases there's silica in the aggregates. So you probably wouldn't want to run into it. Although when you cut asphalt, there's less dust than with concrete, but there still is a fair amount of dust. So I would cheat to the safe side and assume there is.
Another question, is the quote-unquote written exposure control plan required by the new regulation?
Yes, every company would be required to have that. And I don't have a ton of information on what that's supposed to look like, except essentially it's saying, if I'm going to create dust with this activity, how am I going to control that dust? And the answer to that might be, I'll adhere to Table 1, which is the simplest way to do it. It might be, I'm going to be testing the air quality. I have air monitors. But in our industry, that's really difficult to do because you could test the air quality on a job. By the time you get your test results back, you're on to the next job. So that's why that Table 1 is really, it's a crucial document for us as small contractors because we move around so much. There's really, I don't think, any other way to really handle some of the regulations and how to be compliant.
A note from one of our other attendees about the aggregate question said aggregate does have silica, so there is a chance there is silica in asphalt. He just wanted to add that.
Yeah.
I'm assuming the same question. I think this is what the individual meant. Is there silica in polymeric sand?
Again, I'm not 100% on that, but I'm going to I would say yes. The likelihood of it being in polymeric sand is rather high because some of the polymers, well, not in all cases, but some of the polymers are actually, like a Portland cement type of material. So I would, with dust and silica sand, I would probably wear a respirator in that scenario as well.
Again, from the same attendee, he mentioned milling, cutting, or otherwise disturbing asphalt pavement can create airborne dust containing silica. Water spray plus ventilation controls are collectively considered to be the best practice approach to asphalt pavement milling dust control. Another question, Tim?
Yep.
Is it required to wear a respirator while wet cutting?
I don't have the Table 1 chart in front of me, but I do remember and recall it depends on the scenario. If you are outside and wet cutting, I'm pretty sure the answer is no, you're not required to wear the respirator. I believe if you're inside and cutting wet, you are required to wear a respirator. So that's, again, that Table 1 will really answer a lot of those where it's like, okay, well, I do this, do I require it? Table 1 will probably have that on there. So I'm pretty sure it's going to depend on where you are and what your scenario is as to whether it's required.
And a follow-up on the polymeric sand issue, this is from another attendee. The primary ingredient of jointing sand is plain silica-based sand. Sand or silica makes up 80 to 95% of the mixture and is the primary ingredient in jointing sand. It is often called polymeric sand because of the chemical binder that is put into the mixture. The sand that is used is the same sand. So another question, is there a guideline of what dust collection systems are compliant and which are not for a table saw, for example?
If there is a specific guide for that, I am not aware of it. But in doing some of the research I did, I had mentioned that if you Google this, OSHA compliance, there's a lot of information that is being disseminated from saw manufacturers and vacuum manufacturers and that kind of down that line. And it's a lot of great information, and the saw manufacturers are aware if their equipment is compliant. And a lot of that has to do with the filtering system, the horsepower, the vacuum, and all of that kind of stuff. So I have not seen specifically a list that says here is what needs to happen. I've kind of seen bits and pieces of it. Most of it deals with the filter and the horsepower of the equipment.
Another question, under the law, are there any responsibilities that the contractor has towards their residential customers in terms of communicating to them about the hazards of silica dust?
I have not heard of any, but I'm guessing that this law is widespread enough to where homeowners are going to know about it. At least some of them will. And one of the things that I talked about kind of towards the end is restricting access to the area where cutting is occurring. And so that would include, you know, the homeowner and the family. So if, you know, you're cutting in their backyard and they want to come out the sliding glass door into the backyard while you're cutting, you are required to keep them out of that specific area. So are you required to tell them about it? I have not heard that you are, but you are required to keep them out of the area while you are creating silica dust.
A few more questions. Are there any requirements for eye protection?
I think those are general OSHA requirements from a personal the eye protection does not specifically go to this new regulation. That would be a different OSHA regulation, I think, from a safety standpoint.
And also, does equipment used for wet cutting have to be certified by OSHA?
Not that I have heard. I have not heard any regulations on certification of specific equipment. The only thing that I'm aware of, like we talked about, is that the equipment that you're using for wet cutting has to be made for that particular piece of equipment. The water system has to be made for it. You can't just take a hose and duct tape it to the saw and call it good, which I have seen.
We have time for maybe just one or two more questions. If anyone would like to ask before we end the call.
Well, I appreciate everybody coming on this morning, and
Tim, I just have
one more here.
One last question. What happens if you don't have a certified competent person and OSHA shows up? Is there a fine if the competent person is not certified?
That's one of those kind of gray areas. I have not heard. My guess is there would be a fine because my understanding is if they're not certified, they are not considered a competent person. So part of the competency is going through the training and being certified. And if you cannot produce somebody with that certification, my guess is there's going to be some sort of fine involved with that.
Well, we will end it there. Tim, on behalf of the Illinois Landscape Contractors Association, our members, I just want to thank you for lending us your expertise today. This was great. I hope this answered a lot of questions, and I completely understand what you mentioned about a lot to go through and a lot to unpack here in a webinar format. And so I hope that the ILCA can continue to provide deeper dives into this content or other organizations that this impacts, because obviously the health concerns can be grave. Thank you very much, everyone who did attend. We will be ending the webinar now, and we'll be sending out an evaluation survey that I hope that you please take, and then also we will be posting the video of the webinar online relatively shortly. So thank you all for attending, and please have a safe and productive season.
Thanks a lot.